Morning, everybody. Thank you for joining today's meeting on sustainable materials, opportunities, and challenges for the automotive sector. So this is Cal Mahoney with Suppliers Partnership for the Environment, and I'll give a few brief opening comments before turning over to our speakers today. So first, I do want to note that this is a presentation that is being recorded, and we will share a link to the recording after the presentation concludes. If you have any questions, while the speakers are presenting, please feel free to use the chat window to note your questions, and we will get to as many of those as possible at the end of the presentation. So as a quick introduction here, for those that might not be familiar, Suppliers Partnership for the Environment provides a forum to bring automakers and suppliers together to collaborate around environmental sustainability goals, for the automotive industry and the extended value chain. And, in our work today, a lot of the focus has been around facilitating communication and collaboration across that value chain, around shared environmental sustainability priorities and goals of our member companies. And certainly, while those goals encompass many things, sustainable materials is one big component of that. And in recent years, we have seen an increase in sustainable material content goals, among our member companies and others in the automotive industry, and within Suppliers Partnership have been working to improve understanding of the different ways in which those goals are set and measured and how they extend and relate to the supply chain. So for today's meeting, pleased to have, two of our member company representatives from Ricardo here to share the results of some research that they have recently completed on behalf of an organization in the UK regarding sustainable material trends, challenges, and opportunities specific to the automotive sector. So to get us started, I will turn over to Andrew, the head of circular economy for Ricardo, to introduce himself and his colleague, Michael.
Thank you. Thank you very much. And hello, everybody. And thank you for joining our call today. So as you've already heard, I'm Andrew Dunwoody. I'm head of circular economy at Ricardo. I have over 20 years experience in the waste and circular economy sector, but I've been leading the circular economy team at Ricardo for just over 2 years now, where we look to create circular economy strategies, create circular economy indicators, and also promote sustainable packaging and procurement with our clients across a number of different sectors, both public and private sectors, but obviously a lot of focus on the automotive sector, where we have been working with tier ones and OEMs internationally on their circular economy approach for quite some time now. So I will be doing most of the presentation, and I'm supported today by Michael, who hopefully will be able to say hello as well.
Yeah, hi, I'm Michael Campbell. I'm a principal consultant in the sustainable transport team here at Ricardo, where we support clients with policy and strategy development and meeting their carbon reduction and sustainability targets. I'm a mechanical engineer by training with 20 years previous experience in the Ricardo Automotive Engineering Consultancy, where I had a focus on reducing the in-use emissions of both air pollutants and CO2 from vehicles. However, at Ricardo, we are increasingly supporting manufacturers, suppliers, and policymakers in understanding the life cycle emissions of their vehicles.
Thank you, Michael. So today we would like to just provide a very quick introduction to Ricardo for those of us who aren't aware of the company. Then I will do a little bit about the importance of circular and sustainable materials in the automotive sector from our perspective. Michael will then return with the main event for today, which is the case study on demand-led materials innovation for the automotive sector, that research piece that you've already heard described briefly. And then I will wrap up with a few thoughts on next steps for automotive businesses, and we should have time at the end for questions, and we will do our best to answer all of those before we finish. So just quickly coming in then. So Ricardo, we're a global strategic environmental and engineering consultancy company. We've been around for over 100 years. We're based in the UK, but are represented in over 23 countries worldwide. Our background is actually directly in the automotive industry where we started, and obviously we've branched out quite a lot since then. We've now got over 3,000 employees worldwide. So we are really focused today on providing engineering support, strategic advice, and policy analysis for our clients. And the focus of today's webinar is going to be on policy, where it's a core area of work for us at Ricardo, where we regularly provide support to policymakers around the world. In the EU, where most of our staff are based, we have extensive experience of working with the European Commission and the European bodies, supporting on specific policy development initiatives, including the automotive sector. And today we're going to bring you some of those insights, particularly on how policy around sustainability is evolving in Europe and elsewhere, and what the implications are for the automotive sector all around the world. So then just really coming into what is the circular economy and why is it important to the automotive sector? Sort of assuming that everybody on the call is familiar with the circular economy, but really at Ricardo, we think of four main drivers why it's important to the automotive sector. And first and foremost of those is climate change. Obviously, we're in the middle of a climate crisis, and so all organizations, be they big or small, public or private, need to do their bit in terms of tackling climate change and understanding how they can contribute to mitigating the changes that are happening around us. And really, I always think it's impossible to think that we'll successfully tackle climate change without properly embracing the circular economy. And that's the circular economy that looks to minimize waste, use resources more efficiently, eradicate polluting and toxic elements, and also be regenerative in nature. And so those key elements of the circular economy are something that are really going to be important as we tackle climate change, and are really important then to be embedded in the automotive sector as it looks to tackle climate change as well. The next key element for driver for the circular economy is investor pressure. And really, I think it's clear to see that investors and shareholders are looking to invest their money more ethically, and that's becoming an increasingly important element of what they're looking for their investments. And so being able to point to a clear circular economy approach that does minimize waste and use resources efficiently is really important in terms of keeping current investors happy, but also attracting new inward investment as well. And so being able to not only deliver on the circular economy, but being able to clearly measure it, report on it robustly and transparently, and to show investors that you are walking the walk after talking the talk is going to be really important. And the circular economy can help do that clearly. The third element of pressure then is market pressure, and it's clear to see that consumers and customers are expecting their products to be more and more environmentally responsible as they look to reduce their own environmental footprints. And so it's really key that the automotive industry is starting to embrace a lower environmental impact, and circular economy is an important part of that as it reduces waste and increases resource efficiency and embraces new business models that can help deliver those. And it's not just environmental impact as well, like the circular economy can help deliver as well. Here, we see a lot of market pressure around social values as well. And the circular economy can help contribute towards social value achievement as well, and really can deliver around the triple bottom line of sustainability, which is delivering on economic performance, environmental performance, and social value performance as well. And the fourth driver for embedding the circular economy is regulation. And I think that's probably clear to everybody and obviously apparent to all industries, but particularly the automotive industry. Here in Europe, we've seen the Green Deal from the European Union set out clearly how the European Union hopes to drive a new economy around green credentials. And then that was closely followed by the Circular Economy Action Plan, which was the foundation stone there for a whole raft of additional legislation and policy, some of which is directly related to the automotive industry and some of which is indirectly related. So I'm thinking of things like the end of life vehicle directive and the sustainable batteries regulation, but then also other regulations around waste management and critical raw materials also came from that Green Deal. And so they're all driving a change of performance in the automotive industry, and clearly circular economy is going to be very important for that. But elsewhere around the world, we're seeing other regions and countries follow that as well. And I think that's also apparent within the US. And we've seen recently things like the Inflation Reduction Act and the new emission standards coming out that will drive different performance within the automotive industry. And the circular economy can really be a key tenet in terms of how the industry is responding to that and delivering upon the obligations that are being placed upon them. And so just really, this is how we like to graphically display the circular economy at Ricardo, particularly for the automotive industry. And you can see here that we've got a circular approach around a central thinking of circular economy with raw materials coming in and hopefully a decreasing way as we look to reuse the materials we have, and that there is no waste. So in an ideal circular economy, we've eradicated waste, and so there's no outputs and no waste or leakage from this system. And it's no mistake here that we have design at the top of our system above production, distribution, consumption, and recycle. We'll come on and talk a little bit more about design and the importance of circular design later, but this is really just helping to show and clarify what we mean and think of with a circular economy when we look at that for the automotive industry. And so just before I'd like to go any further, I'd like to run a very quick poll with the audience we have today. And so hopefully we'll get some voting buttons quite soon. But I'd just very quickly like to ask you, what do you see as the greatest challenge with materials in transitioning towards circular economy in the automotive sector? And we've got 5 choices there, and I'd like you just quite quickly to select which one you think is the greatest challenge. Is it high resource demand, reducing carbon emissions from manufacturing, growing costs, supply chain pressures, or policy and regulation? And I'll give just a few moments, please, to allow you to vote, but just to gauge a little bit of an opinion around the room of how people see the biggest challenge for the automotive industry.
All right, we've got 70% of the attendees having responded. I'll give it another 15 seconds or so here, and then we'll share the results.
Thank you. Thanks, Kellen. So this is obviously very unscientific, but just a chance for us to gauge what you think before we go on with our presentations today.
Okay, I see we've got almost everybody, so I'm going to go ahead and end it here now. And there is a very clear top choice here. So hopefully everybody is seeing that now. But
That's
if you're not, Andrew,
yes, I am.
The top choice is growing costs.
I don't want to brag, but that's what I thought might be the case. But thank you very much, Kellen. Yeah, so we have got choices and selections across each of those 5, but we can see very much that growing costs is a real concern around the room, and that's just really interesting. Obviously, it's just a very quick straw poll, but something that we suspected and interesting to know, and hopefully we can help continue to talk about that as we progress through our presentation today. So thank you for participating in that. And Ricardo, we really see all 5 of those challenges as really key for the automotive industry. It's really hard to say that none of them are relevant or one is clearly more important than the other, but each of those present their own challenges and are important in their very own way. But really the circular economy can help address each of those, and it's something therefore that we think is circular economy and embedding a circular approach in the automotive industry is absolutely key. When it comes to high resource demand, obviously the automotive industry is very resource intensive, and so providing a value retention type solution is going to be really important. Promoting value retention through a retention of materials, components, and vehicles, thinking of things like remanufacturing and refurbishment, looking at how things like continued ownership or material stewardship type approaches through different business models can really help tackle that resource demand and reduce the resource demand indeed, and help mitigate those impacts. High emissions linked to greenhouse gases and therefore climate change are something I've already touched upon, and obviously recognizing that we have a climate crisis, and reducing embodied carbon is something that circular economy can help deliver as well. And so that's going to be something that's very important for all organizations, be they in the industry or not, but somewhere that circular economy can really help to reduce that embodied carbon and help contribute to tackling climate change. Growing costs, we've clearly seen that that's probably foremost among the minds of the people in the call today, and I'm not surprised at all. But again, the circular economy can really help tackle that. Savings through recycled content, advanced recycling technologies, and end-of-life treatment are all things that can help tackle that growing costs, and the circular economy can help contribute to that through the business models and the different types of processes, and looking at that whole value chain type approach is something that the circular economy can clearly contribute to. Supply chain pressures we've seen elsewhere as well are a worry in some industries, and I don't think the automotive industry is immune to that. I think recent global events such as the war in Ukraine or the lockdown before that showed just how fragile some supply chains can be, and so therefore it introduces other risks. And so improving supply chain resilience is really key and really an important element in today's world. And again, the circular economy can help provide that supply chain resilience, reducing uncertainty and helping to improve those deliveries. And then policy and regulation. Again, it's something I've touched upon. I've described a little bit of what's like here in Europe. They'll touched a little bit on some of the things that we can see here developing in the US as well. But understanding current and future regulation is really important. And the reason I emphasize the future regulation element of that is being prepared for future regulation is a really important position to be in. And again, a circular economy approach, looking at regulation obligations, and then also being ready for future ones that are coming down the pipe means that the business can continue on and mitigating risk and ensuring that there's going to be a continuity of supply and success. And alongside those more general challenges, there are also various other material innovation specific challenges. And I've already mentioned the end-of-life vehicle directive here in the EU, but this is of particular importance to us, and we think that it's going to be followed elsewhere around the world as well. But it's going to result in a number of targeted legislation and targeted challenges that will be apparent for the automotive industry. And just the top 5 of these that we've picked out that you'll hear a little bit more from in Michael's presentation is the need to replace materials with alternatives to achieve lightweighting, which will contribute to greenhouse gas reductions and obviously the climate change impacts associated with those. There's also going to be a need for lower carbon options and move away from conventional materials and again linked with the embedded greenhouse gases and the climate change impacts. There's going to be a need to increase availability of recycled materials, and that's one of the key challenges that we're seeing here in the UK for industries related to the automotive world, and how they can secure those recycled supplies and how they can match the obligations placed upon them by regulation. The need for innovative solutions that also reduce cost is going to be imperative. And so again, looking at other sustainable materials or lightweight alternatives as well is going to be key to that cost reduction. And then there's going to be a need for OEMs to improve the sustainability, performance and credentials of materials as well. And again, driven by this directive that we expect will be followed elsewhere around the world is going to be a key challenge for the automotive industry. But some of these are drawn out within the case study that I'm going to hand over to Michael now for him to talk through in a little bit more detail. Thank you, Michael.
Thank you, Andrew. So we are going to be looking at a case study that we completed recently for Innovate UK, who are a publicly funded innovation agency tasked with helping UK industry grow through development and commercialization of new products. This project aimed to enable foundation industries to understand and adapt to the changing demands of automotive materials. This is against the very background that Andrew has just been discussing. So the automotive sector is adapting to produce electrified vehicles. Manufacturers will also need to decarbonize their production operations and their supply chain and increase the circularity of materials, all driven by the factors that Andrew has been discussing. The supply chain includes foundation industries, with the automotive sector being a key demand for metals, chemicals, and glass, for example. Foundation industries will themselves need to adapt to reduce their own carbon footprint while delivering materials that meet the future demands of automotive manufacturers. Now, we're only one investment cycle away from 2050, by when the UK's foundation industries should have reduced their emissions by at least 90%. So there's a real challenge in terms of timing and investment. This study aims to explore demand-led innovation for the automotive sector and how interventions could support the development needed to meet that demand through building cross-sector collaboration. Stakeholder engagement was at the heart of this study, and that included interviews with automotive OEMs and a roundtable workshop event with wider industry stakeholder engagement. The engagement was used to build upon and to validate the findings from a literature review, to explore the barriers and challenges and the potential for support through intervention. So work commenced last October. An initial findings report, which was based on the literature review, was published in March. The roundtable event was held in late February this year. The findings were recently presented at the Materials Research Exchange Conference, which was organised by Innovate UK in London, and the final report will be published shortly. So the key material groups explored in the study were identified considering UK influence on their supply chain, their innovation potential, and the sustainability of the materials. The focus was on those that exhibit a high share of the vehicle weight and significant UK production rates. And the 5 shortlisted materials are shown. They're the steel and cast iron, which make up the largest share of vehicles by weight, and are currently predominantly made using high carbon production methods. These are easy to recycle, but the challenging demands of the automotive sector means recycled steel cannot always be used in vehicles, as it is usually of a lower quality. This is something known as downcycling. Aluminium is an obvious lightweight alternative to steel, and it can have a low carbon footprint, but it's not a like-for-like replacement, requiring different design and assembly. Its recycling faces similar downcycling challenges to steel as well. Plastics and composite materials are attractive for reducing vehicle weight, but may be challenging to source sustainably and to recycle. Copper, of course, vehicles are using increasing amounts of copper with electrified vehicles and with additional wiring and electrical components, of course. Glass is a heavy material for which demand is unlikely to change significantly, and it's currently made with high carbon, energy intensive processes. And that also has recycling challenges in automotive applications. So 3 key material innovation challenges were identified through the literature review, and these were reinforced through the stakeholder engagement. Andrew has already touched on these, but we have the reduction of vehicle weight or lightweighting, which reduces the vehicle's in-use energy demand. And so obviously the CO2 emissions from the fuel use of that vehicle or the electricity production to drive that vehicle, and so reduces greenhouse gas emissions in that use phase. Reducing the embodied greenhouse gas emissions in materials, which requires low carbon production methods, renewable power, and in some cases the use of alternative materials to give low carbon material options. And then increasing and improving the circularity of vehicles, which means increasing both the recyclability of the vehicle at its end of life and the use of recycled material in its production. Recyclability means easy separation of vehicles at the end of its life. And increasing the recycled material use in vehicle production requires an understanding and improving the quality of the recycled materials that can be used. These challenges can contradict each other. For example, lightweight materials may not be low carbon or easily recycled or recyclable. Further challenges were identified that apply to all 3 of the key challenges of lightweighting, low carbon materials, and circularity. These are making innovative materials cost effective. We saw that in the result of the survey. And this is especially true when these materials are not being produced at scale, or at least not yet. Ensuring materials are sustainable and understanding how sustainability is evaluated and compared to inform the design and procurement decisions. Ensuring a robust supply chain for innovative materials, while also ensuring that they are of a consistent and suitable quality for use in the automotive sector. And commercializing and scaling up the production and supply of innovative materials means increasing capacity and upskilling within the supply chain. The stakeholder engagement made clear the need for development in standards and policy areas to remove barriers and to incentivize the use of sustainable materials. These include ensuring materials meet the performance requirements or grades required of automotive applications, and that manufacturers have confidence to use them in their products. Understanding the environmental impacts of materials over their full life cycle in a comparable way. Using regulations such as the European End-of-Life Vehicle Directive that Andrew had mentioned and its UK equivalent to increase the use of recycled materials in vehicles and to increase their proportion recycled at end of life, including specific targets for low-weight materials such as polymers. Removing the barriers to and supporting the development of new recycled materials facilities, including reducing waste export to incentivize recycling, and enabling cost-effective access to renewable power and to green hydrogen supply for foundation industries, potentially through local schemes and clusters. So in terms of potential interventions that can address the key challenges, this was informed by the roundtable event, the stakeholder engagement, and Ricardo analysis, and we carried out a shortlisting exercise according to their relative importance, urgency, and relevance based on the feedback from that roundtable event. Development of interventions can focus on overcoming barriers identified by supporting research targeted where the development of materials or production methods requires it, including cross-sector development challenges. Using demonstrator projects to showcase how innovations in materials can be adopted in vehicles and how integrated supply chains can be used, and therefore providing confidence to both the automotive and foundation industries to invest in innovative materials and establish those integrated supply chains. Research and demonstration project themes proposed include supporting the development of innovative material solutions with low environmental impact relevant for the automotive sector, exploring how lightweight or high recycled content materials can be deployed in vehicle production, considering design and manufacture. A particular challenge was identified around lightweight structures for heavy goods vehicles, given their loads and duty cycles. Improving vehicle recyclability. This means designing and producing for effective disassembly and separation at the end of life, a process involving vehicle manufacturers and disassemblers. Improving material separation can improve the quality of recycled material, enabling it to meet the grades required for vehicle production, and so enabling the increase of recycled material content in vehicles. Closed loop supply chains, these bring together vehicle end of life and manufacture processes to facilitate circularity, improve recyclability and recycled content, and require cross-sector collaboration and commitment. Interventions that support building capacity can improve the cost effectiveness and dependability of the supply of innovative materials, and that removes the barrier for their use in automotive applications. Significant changes in vehicle design and the materials they demand is expected to require rapid changes in material supply chains. This will require training to deliver different assembly processes that may be required for the use of those alternative materials and for enabling their disassembly. Upskilling will be required within the steel industry in particular, as high-grade, low-carbon steels will be needed by automotive manufacturers. Automotive manufacturers demand quality materials at scale and low cost. Scaling up production of innovative materials suitable for the automotive sector enables costs to be reduced and robust supply chains to be built. This commercialization process requires investment, such as providing the larger and smarter facilities that will be needed to improve cost effectiveness and produce materials with higher grade properties, and financial support, such as loans and grants, potentially that can both support capacity building and commercialization, but also provide additional value in attracting private investment. The challenges identified in the study relate to both the automotive manufacturing industry and the foundation industry supply chain. A key finding is the need for cross-sector collaboration to address and to overcome the challenges and to help guide interventions. An objective from the start of this study was that an output would be the forming of a cross-sector forum enabling collaboration. interested companies and organisations have been identified to initiate a stakeholder community within the UK, led by the Transforming the Foundation Industry Challenge. And so the project outputs the study website, which can be accessed via the web link there that will be shared afterwards, along with the slides. The preliminary report, which covers the literature review, identification of key materials, and initial findings of the challenges, is already available on the website. And the final report will be made available on that website shortly as well. We expect it to be available very soon. It's hoped that the findings will be useful to both the automotive and foundation industries and to policymakers, as well as to the study sponsor, Innovate UK, as they look to support industry in meeting these challenges. And although the focus in this study was on the UK, many of the findings will also be relevant to other markets with common drivers to decarbonise vehicle production and material supply, as Andrew was introducing earlier. So I'll now hand back to Andrew to take us through the next steps for automotive businesses.
Thanks, Michael. So yeah, as Michael said, we'll just very quickly wrap up now with sort of what we see as the next steps for the automotive industry before we come on to questions. And from our point of view, really, we base this around the creation of a sustainable materials strategy and what we see as the key steps for that. And there are 6 laid out here on the slide in front of you, which I'll go through in turn just very briefly now. So starting with recyclability assessments, the improving the environmental sustainability of vehicles starts with understanding the current situation. Analyzing materials use, vehicle design, engineering, and production all contribute to understanding a vehicle's recyclability. This, at Ricardo, we've done this quite a lot and usually would follow the international standard on this. And we've got a case study here, just very briefly, of where we've done this recently for an automotive OEM in the US. So they were interested in improving their sustainability approach and sort of transitioning into a more sustainable company, and really wanted to understand how their vehicles stood up under scrutiny in a robust and transparent way. So we were able to take their bill of materials from each of the vehicles that they wanted us to examine, apply this standard and tailor it for their exact needs, which was a key element of our offering for the company. And then we were able to give them clear and transparent and robust information around the recyclability and recoverability of the 2 vehicles we looked at on their behalf. And then so we were able to then recommend next steps about how to start to improve that recyclability and recoverability. And what that really meant for this organization was that they were able to then clearly understand the recoverability and recyclability of the vehicles that we had studied, which was able to then provide inputs into their sustainable strategy and help them take them on their journey, and then also help them set targets about how they can continue to improve their sustainability according to their objectives. I think one of the key things here with using this international standard and tailoring it specifically for the needs of the company was that it was very robust and fully transparent, and so therefore the company was able to report this with absolute confidence that there was not going to be any sort of comeback in terms of accusations of greenwashing or manipulating results to make them seem better than they were. They could be absolutely confident around the recyclability, and also then set some targets that were realistic in terms of how they could improve their performance in terms of sustainable materials going forward. Then just coming back then to the other steps of a sustainable materials strategy, a materials market assessment is very, very important. With an ever-increasing complexity of materials, the recycling industry has developed significantly over the past decade, and I'm sure we're all aware of that. But chemical recycling, the production of high-grade recycled plastics, and the recycling of EV batteries are some of the examples on this. Increasing governmental and consumer demands for sustainable transport has led to an increase in the reuse of recycled content. And I think this is one of the key challenges for the automotive industry, is that recycled content, securing that and then being able to incorporate that into the new products, providing the evidence so that the provenance of that material is clear and robust, and avoiding any accusations of greenwashing or manipulating of results is absolutely key. Sustainable packaging is the next key element we see as of a sustainable materials strategy. Obviously, packaging forms a huge proportion of any waste stream, and I've mentioned several times this morning about how we are looking to reduce waste, and so looking at a sustainable packaging approach is really key to handling material strategy, and whether that's looking to change packaging to make it more sustainable from a reuse point of view or a reduction point of view, or whether it's looking to innovations to make those materials themselves more recyclable or less damaging, and looking for innovation in that direction. It can be either, really. And so at Ricardo, we've got a sustainable packaging team that fits part of my role, and very able to understand and help people look at sustainable packaging innovations. And we actually have a database of packaging innovations that we can use for our clients to be able to help make recommendations around innovations that can improve their performance. And I should also point out as well that the ESP have recently produced a sustainable packaging guidance for automotive manufacturing operations. That's now in its 3rd edition, which has just been published, and is a really useful document to help get started in terms of looking at how packaging within your operations can be more sustainable. And then I mentioned earlier about circular design, and that I would come back to that in a little bit more detail. And I don't want to labor this point too much, but obviously that's absolutely key for a sustainable materials strategy. And in this instance, I like to think of circular design as both a push and a pull factor in terms of achieving more of a sustainable materials outcome. So circular design can push for the inclusion of more sustainable materials, and be they recycled content or from alternative sources such as renewable sources or lower carbon sources, but can also pull in different elements as well. So making the outputs and the deliverables of the design process more reusable, may have longer lifespan, so more maintainable and repairable, and then also making those components and different parts available for remanufacturing and refurbishment where possible, and then obviously making them ready for recycling and reuse in that way if possible. So circular design can clearly act as a way for a push and a pull in terms of making sustainable materials more evident in automotive outputs. Again, life cycle assessments are a key element of a strategy. And again, this is something where there's a dedicated internationally approved approach that can help guard against any greenwashing. So a life cycle assessment will look at a life cycle assessment of an individual product, or indeed a whole product, and if that is if that's got multi-components, and help deliver a clear assessment about the impacts from that across its entire life cycle, pointing out hotspots that can be improved upon, and again, can help then improve overall sustainability. But as I mentioned, this can be clearly linked to an international standard, and so guard against any greenwashing or any accusations of manipulating sustainable outcomes. And again, just a very quick case study on this. We've recently completed a comparative LCA for a large automotive OEM, where we were comparing an ICE and EV vehicle from the similar chain, but with those different engine types. And so really the customer in this instance want to understand the differences across a whole life cycle element, and then be able to confidently promote electric vehicles based on their own merits. So for our solution for that client, we were able to do a policy review and make sure that we picked best practice for that, for the life cycle assessment. We then delivered a comparative life cycle assessment based on that best practice that we could clearly document and publish, so that it was fully transparent, replicable, and reliable. And then we did the complete review of the greenhouse gas impacts of the material types and the battery recycling technologies that were likely to form part of that whole life of those vehicles. And then from the outputs that we were able to provide for the client, we're able to identify life cycle hotspots, like I've already said, so the client had a clear idea about how they can improve the sustainability of those vehicles. The tool that we provided for the client gave them enhanced internal capacity to be able to undertake more LCAs going forward. And then the client was able to confidently encourage the uptake of EVs, because that was based on sound, transparent evidence that we had been able to produce for them, and there was no fear of recriminations or comeback or contradictions. And then one last point, just to point to in terms of elements of a sustainable material strategy, we would recommend that metrics either around circular economy or broader sustainability are adopted to be able to monitor and report upon progress towards achieving more of a sustainable materials approach. And within my team, within Ricardo, it's something we've done a lot of. We're currently actually just concluding a project with the European Union where we are advising them on all of the circular economy indicators that the European Commission want to adopt going forward. And so we're supporting them for the next 25 years, thinking around policy based on circular economy indicators. We've looked at over 700 for them, and we've boiled those down to a short list of just around 60, and they will be shortly publishing some guidance around how those can be employed across numerous different sectors, and the automotive is obviously one of those as an important element of the European economy. And so something that we would strongly recommend the automotive industry looks to embed robust and transparent circular economy metrics to be able to clearly report upon their activity, but then be able to monitor and report upon progress and successes as well. And so just before I finish up then, I'd quickly just like to point out that within Ricardo, we've got a wide range of skills across all of these different functions and beyond that you can see on your screen here. And so if there are needed any support around any of the things that you've heard today, please do just reach out and contact us, and we'll be able to provide more of an insight into the different skills and services that we can provide to any of the companies. And at that point, I'd just like to say thank you very much and ask if there are any questions. I think I've seen a few come in on the chat, but I'm not quite sure how to open the chat. So I might leave it to you, Kellen, if that's okay, to read the questions for us and chair this session, if that's okay.
Yes, absolutely. And thank you, Andrew and Michael, for the very interesting presentation. So there have been a number of questions and comments that came in as you were presenting. And I think I'll start with this one around just definition. So as the study looked at sustainable materials, was there a particular definition that you were using to define what is a sustainable material and what criteria that includes, whether that's solely environmental or it's also looking at human rights and other aspects related to that material?
So in terms of the study that we did for UKRI, it was just looking at the environmental impacts and predominantly the greenhouse gas emissions. Of course, there are wider definitions. There is increasing interest, of course, in ethical and human impacts of materials. And we are starting to see that come into some of the European legislation, particularly. I'm sure Andrew can build on that more, but there is a corporate sustainability directive, I think, planned for the European Union, and things like the battery passports that are being introduced in Europe as well will consider those aspects. Do you want to add, Andrew?
Yeah, I think you're absolutely right. Is obviously the thing that most people commonly think of is when you talk of sustainability is are the environmental effects, but we definitely like to consider it as the sort of a triple bottom line. So it's the economic impacts, the environmental impacts, and the social impacts as well. We're looking at sustainability, I think it's very easy to find legislation that points towards environmental impacts and how those can be reduced. But I think social value is not far behind, and yeah, as you've said, the European Union is definitely now bringing that and introducing that into much more legislation and expecting there to be much better performance around the social value that comes with those impacts, and you're expecting that your employees will be given rights, that there will be no modern slavery or any other sort of human right compromised throughout the entire supply chain, and people are now starting to expect that they can see that and have transparency around that as well. So I think it's only now being introduced into legislation, but that's, I think, from where we sit anyway, that's only going to be increased, and so social value is an ever increasing part, and so that's why we're starting to introduce it into presentations like this, and advising our clients on how they can be ahead of the game, as it were, on social value, and we fully expect that that will continue, but recognise as well that it's very important for businesses, and that it's good businesses as well. If customers, employees, and investors can see that companies are genuinely dedicated and committed to improving social value, then that can only be a good thing.
Excellent, thank you. So there's another question here around the point where you ended, Andrew, on circular economy indicators. So the question is, ISO has recently released some circular economy standards. Could you speak to how that might relate to the work that you're doing with the EU, and whether those efforts are in alignment?
Yeah, yes, absolutely, they are. We've looked at that and considered that. So we threw the net very wide whenever we were looking at those indicators for the European Union, and this is a very forward-looking piece. So really, I think the European Commission thought it was time to take stock of where they are, because I said we ended up with a long list of over 700 indicators for our project, and looked at that ISO and various other international sources of indicators. And I think the whole ethos behind the project was that it becomes such a crowded field with so many indicators at disposal, and more being developed all the time, that it was time to sort of narrow down, from the European Commission's point of view, narrow down and be able to pick out ones that were particularly important to achieving their objectives and delivering upon their directives, and then being able to make sure that the data was going to be available for reporting around those indicators going forward. And so it's the start of a long process, but we're very proud to be sort of at that cutting edge thinking with the European Commission around what those indicators look like, and how that will inform policy and data requirements going forward. We've something we've helped many of our clients with as well, in terms of identifying indicators, but also tailoring those and developing them for their own usage, and then their reporting as well. So being able to clearly show how well they're doing in circular economy, how help set targets around their ambitions, and then show the progress towards those as well.
Great, thank you. So there is a more specific question here, I think, around that alignment. How does Ricardo reconcile between Directive 2000/53/EC vehicle and ESPR rubber?
That's a very specific question. I'm afraid I would need to look up the number of that directive. Is there any more detail in the question? Or are you aware of that, Michael, at all?
That is all, but I guess for the individual that asked that, maybe if you could provide more detail in the chat. And
yes, of course. Yeah, we would happily take that away and come back with a much more comprehensive answer.
Okay, sounds good. I'll move on to another question here. Does the study show lack of recycling infrastructure and cost of recycling as a barrier to commercialization of new design to recycle materials? And are there any suggestions of how that might be addressed?
Yeah, I think it's fair. That was feedback from the stakeholders. There were suggestions that it's perhaps cheaper or more preferential commercially to either export waste or to send it to energy from waste type incineration plants, rather than perhaps feed it back into the circular economy, which is maybe a law of unintended consequences. I think there's many different reasons for that, and potential ways to address it. We are certainly suggesting that perhaps restrictions on the amount of materials are exported. Certainly, if they could be recycled within the UK. There's also that need to sort of scale up the plants, as we talked about, the sort of commercialization of the production of those materials to bring down their costs, and in terms of increasing the demand from manufacturers for those type of materials, which is of course happening through some of the legislation that Andrew's talked about. So I think there's changes at different levels that could be implemented to improve that.
Excellent, thank you. So there's another question here about the LCA case study you shared, Andrew. So the question is, how was the LCA study performed on ICE and EV? Was it on a software or another way? And how detailed was it, and what problems did you face?
It was done on a software approach. It wasn't within my team, so I'm afraid I can't tell you what type of software it was done, but it was done basically on a bill of materials type approach for an entire vehicle. So two comparative vehicles with different engine types, two same vehicles with just different engine offerings. And so the biggest challenge there was just getting that level of information, and then being able to transpose that or upload that onto the tool that was used. I think that's a common challenge with LCA, and particularly when you're doing it something at vehicle level where you've got so many different components, so many different inputs to production of that vehicle, and then trying to make that comprehensive, through from cradle to grave. So understanding where the materials have come from, how they've been incorporated, processed, transported, manufactured and put together into that vehicle, how the vehicle is used, what the assumptions around that, the vehicle usage and lifetime are, and then how the vehicle is managed at end of life as well. So understanding and making assumptions and applying reasonable assumptions for that, it's a huge challenge. So it was a significant project and a difficult one, but as I kept sort of emphasizing, to make it fully transparent and fully robust so that it could be verified by a third party, and then so it was suitable for publication and was totally reliable, we had to go into that full effort. So I think just the obtaining that information and making and ensuring that it was robust and reliable was the key challenge. But beyond that, we think it was very successful in terms of giving the client exactly what they wanted and helping to support the transition towards electric vehicles.
Great, thank you. So there's a couple other questions here, going back to the study. One of them around steel. So you mentioned, there's very specific, high grade requirements for automotive steel. Did the study look at, sort of the chicken and egg problem of the demand for increased low carbon high grade steel versus the lack of supply of that today, and how to incentivize more production from the steel industry in that area?
We certainly identified that. I don't think we were able to go into that in a great deal of depth. It was in the context of the UK, where one of the big steel makers recently announced their blast furnace was going to be converted to an electric arc furnace. And there's sort of concern in the industry about whether that would give the quality of steel that they needed, and would we just be sourcing from offshore, from other blast furnace, or is there an opportunity for a hydrogen blast furnace, for example, to give a high quality of steel, or just improving the ability to sort materials at the recycling stage, to be able to do that recycling and produce a similarly high grade of materials. So, minimizing that downcycling effect. But yeah, we didn't get into a great deal of detail on the steel industry itself.
Thank you. And then, one more question. Did the study take a position on chemical versus mechanical recycling as you looked at circular design recommendations?
No, we didn't. We weren't looking into the sort of mechanics of how that recycling was taking place, and there are, we're aware of various technologies out there, and obviously they're developing all the time. So no, I don't think we were comparing mechanical versus chemical.
Okay, great. And last question here before we wrap up. There's a question, as you looked at those 5 material segments did you look at the potential carbon implications as those changes were made? Was there a measurement of the carbon impact of those potentials?
We were looking at the materials, their sort of carbon impact at the moment and their potential for carbon impact change, like, as I say, steel moving to low carbon production and so on. But we weren't sort of doing a sort of headline, what's the greenhouse gas reduction if you manage to shift to these new materials. That wasn't really our scope.
Mm-hmm.
It was more about the sort of barriers and challenges that the manufacturers would encounter in trying to do that for their own vehicles.
Good, thank you. Well, I see there's been a number of questions and comments, and I think you have Andrew and Michael's contact information. So if there are other questions you'd like to get into more detail around offline, please do reach out. Just beginning to wrap up here, I want to say thank you again, Andrew and Michael, for the presentation. We have shared a link to the study, or the preliminary study, and we'll make sure that everyone has a recording and copy of these slides, so when the final study is released, that you can find it on that website that you provided. For our sustainable material work group members, we will be continuing conversation around these topics, and particularly around the circular economy indicators. So I'm very interested to see when that work is published, Andrew. I think there will be certainly a lot there that we can reference. And so I think with that, we will close the presentation here for today. You will see a copy of the recording link in your inbox in the next few days. Thank you, everybody, and have a great rest of your day.